Okay, welcome back, grade 11s. We've got a few things to do here in this question, and it's lovely because there's so much going on in the question. We've got a cyclic quad, we've got tangents from same point. So the first part I want to do is just run through some of those, because that should give you enough to start playing around if you haven't already been playing around. But maybe it'll help you find, maybe you're on 7 other angles equal to x, and it'll help you just find that last part. So I'm just going to start highlighting some things that are given. Where's my nice shape here? Okay, so we're told that that is a tangent, that's a tangent. Well, if that's the case, then using tans from same point, those will be equal, and we've got an isosceles triangle. So already that angle across at B is equal to that angle there at A. We've got a tangent given to us here, CE, and just check, it did tell us that, right? ABC is a cyclic, AB is to E, FA and FB are tangents. Oh, what? That's not a tangent. We can't use tan chord there. Pity. But we do have a tangent over... Wait, here's our tangent. Let's stick with the same tangent. But it's a nice little check there. Like, oh, it looked like a tangent. No, watch out. That could have got you in trouble or me in trouble. There's a tangent. Definitely, we're told. That's a chord. And therefore, that's going to be equal to the angle in the opposite segment. So that one's going to be across there at D. And the same then is going to apply across there at C, or angles in same seg. We're also given parallel lines. So there's a line that's parallel to that line. And therefore we could create alternate angles. We may even be able to create corresponding angles with an F over there. There might be, is there another... Well, there's some more alternate angles. So there's quite a lot of stuff. We're told that this line segment is equal to this line segment. So there's an isosceles triangle. Those two angles are equal. How do they look equal? Somehow they don't quite look. But anyway, maybe diagram's not to scale. FA is a tangent. So there's a tangent. There's a chord. So that's going to be equal to angle in the opposite segment across there or across there. And there are probably a few more. There's a tangent, there's a chord, angle in opposite segment. I don't know if we did that one. Angle in opposite segment. Wow, lots of things to go. But the first one that jumps out to me was, there's a line parallel to that line with alternate angles. So x, it almost feels like that gets us into the diagram. So we can put here and go x, oh, that's a great one, that's right. That one is x over there. So angle CDB, or you could start labeling these 1, 2, 3. Let's go around here. 1, 2, 3, 4. Up to you if you label like this, or if you... Wait, I'll keep going. 1, 2, 3. Or if you want to perhaps just call it angle CDB, whichever you're more comfortable with. Just label your diagram as you go along. So D2 is equal to x because of alternate angles on parallel lines. And that's got us into the diagram, because if we get rid of that, angle D2 is kind of created or subtended by the points BC, or the lines coming from there, or line segments. So if we created or subtended, say, an angle across there, it must also equal x because of angles in same seg. So there we go. There's an angles in same seg. So let's go for what was next there. That was there to there. So A3 is equal to x because of angles in same segment. Okay, well, if that's x, then B4, well, let's do the same trick to see where it gets us. And I'm really hoping you're pausing and going, no, pause, I want to find them myself, please. Let's see, we've got 2, 6. Okay, so that angle there was created or subtended from those 2 points. Well, we already played the angles in same seg game, but I'm going to create BC as a chord, and there's a tangent over there. So therefore, this angle over here must be equal to that angle because of tan chord. And my trick is kind of working backwards. If I were to use pen and paper, I'd use pencils or my fingers to see that. And let's go. This is exciting. There's so many to find. There's like some sort of treasure hunt going on here. So wait, where were we? Here. B4, hope you're sharing in this excitement, equals x because of tan chord. Now, just one point, because sometimes it comes up. Sometimes I've seen somebody write converse tan chord because they're saying, oh, it's almost like we're using tan chord in reverse. No, tan chord just says that those two angles are equal. If you wrote converse tan chord, that's to prove that a line is a tangent. So it's still tan chord. It's still tan chord, even though it might feel like you're using it backwards. Okay, so that angle there is x. Let's see where else we can get to. Well, the next one that I'm going to see is actually part of what I'm rubbing out, and that is something that we saw earlier, which was a lovely isosceles triangle hiding in the diagram. So, well, not really hiding, perhaps hiding in plain sight. So let's go for here. That line segment is equal to that line segment, creating an isosceles triangle, which means that C1 equals x as well. Okay, well, let's capture that. My colors don't really represent too much, so I know that I'm using all sorts of different colors. They don't really mean too much, so don't worry about colors if they're the same or different color or don't appear. So we've got here that this C1 equals x. C1 equals x because of isosceles triangle. Okay, well, that's useful because if C1 equals x, I'm just going to rub that part out because we've subtended that angle from B and A. So if we can create another angle or subtend another angle from B and A, then it must also be x from angles in same seg. Well, there we go, D3. So D3, zoop, doop, doop. Okay, there we go. D3, not too much fuss, is also x because of angles in same seg. Now, we spotted tangents out there, and we haven't used the tangent, so let's just put the x in here. Doesn't matter which one of those we use. Let's use that one there and see what we can do. We've got that one. That should work well, right? Dunk, dunk, dunk. 4. Where's 4? Come on. So we've got there a chord, and there we've got a tangent. So therefore, the angle between the tangent and the chord is equal to the angle in the opposite segment. So that looks like we've got B1, right? I don't lost count of how many we've got. I'm just going to keep going until I run out of steam, which could be a little while. So yeah, brace yourself. B1 equals x because tan chord. Again, it's just tan chord. We're using it to find angles. So that angle there is x. But now, wait a second. That angle, what else have we got? We've still got a few to go on. Not 3, 6. We still got 2 more to find. That's x. Doesn't that mean that A4 is x because we've got an isosceles triangle? Now, I'm purposely going for a slightly longer way around here instead of using tan chord for A4 just to show and make a bit of a point. And that is, we want to say that this is rather finicky. Okay, that this is an isosceles triangle. So it's tempting to say A4 equals x because of isosceles triangle. The only issue is we were not told that these two line segments are equal. We only know that because they're tangents coming from the same point. So we must make that statement first. So I'm going to make the statement because then we can use that isosceles triangle. So I'm going to say that FA equals FB because of tans from same point. Now I can use the isosceles triangle. So only because of that can I say now, because those are equal, therefore, and I'm going to go from there up to here, therefore A4 equals x because of isosceles triangle. We only know it's an isosceles triangle because of the tans from same point. And I've said it 3 times because it's so important. So therefore, that angle there is x. Now, you may correctly say, wait a second, that was a whole lot of extra work because I could have just looked at the tangent, angle between the tangent and the chord is equal to the angle in the opposite segment, and I wouldn't have had to go through all that rigmarole. Definitely true. But if you use the isosceles triangle, you must have shown tans from same point, even though it comes up again and again. Okay, so there we go. A4 equals x, x. What else? We must surely have another one. Have we got them all, or there's like got to catch them all, right? But we're short of one. So hit pause, because I want you to try and spend a bit of time looking for it. Okay, so have you paused? Have you looked at it? I see one other myself here, but maybe there are more. I must say, when I'm looking at the diagram, I'm tempted to fill up things with 180 minus 2x, 180 minus 2x's, but I don't think it's actually going to get us too far. So I'm going to look on the bottom right here. Maybe use the same method I did, maybe a different one, which would be even cooler, right? So here's a triangle over there. Let's make it, I was enjoying these coming out so neatly. Let's go there, and an exterior angle of a triangle. Well, the exterior angle is equal to the sum of the opposite interior angles. So this angle outside here is equal to this angle plus this angle. Well, this angle on the exterior is 2x. This is x, which means that angle E, well, that must be x as well. Right? Let's just check it. Is x plus x 2x? Indeed it is. So angle E is x because of exterior angle of triangle. Now you may have gone about that a different way, because you might have found other angles in terms of x and then got there. Or perhaps there's another one hiding in the diagram that's equal to x that I've missed. Well, so be it. Okay, cool. So that's that one. We've got a whole lot of things in terms of x, and we're going to look at our final question here, which is prove that AFB, that's this angle up here, is equal to ABC. Well, that's really not going to require too much work, is it? AFB, we've already shown that A4 is x, B1 is x, so therefore I'm just going to sneak part B in here so everything's on screen. And that we said was AFB, well, there's only one angle, so I can call it F, is 180 minus 2x because of sum of angles in triangle coming up behind my head, but you've got the sum angles you can see. And this one here, B2 and 3, well, we're going to look at it in two ways. See if you can spot opposite angles of cyclic quad. See if you can spot angles in triangle. Or, now to take one more step to go exterior angle of cyclic quad. Or angles on straight line, we could do that as well. But no matter how we look at it, angle ABC is equal to 180 minus 2x, and you can choose one of those three reasons. Angles on straight line, because we've got those two angles, B1 and B4. Angles in triangle, because we've got A3 and C1. Opposite angles of cyclic quad, because we've got D2 and 3. I'm going to go for angles on straight line. So behind my head, angles on straight line. Maybe I'll do this and things will look a whole lot better. And with that, goodbye. Maybe see you in the next one.